Hello everyone, this is Shivani, and today I'm going to present you on our major project topic, which is HEALBOT-HEALTHCARE CONVERSATIONS. This is our first phase one work, where we have done pre-processing and model selection for our chatbot. Coming to the explanation of it, first is that we have imported the required libraries. Further, we have taken our data set and read it. This is a shuffled data set. As you can see, the numbers. Further, we have removed the hyphens from our data set, as you can see here before and after, with spaces. Next, we have checked for null and not a number values. So we have these many null and not a number values in our data set. This is the graph plotting of it for all of the symptoms, how many null and not a number values are present. In the next step, we have removed the trailing spaces from the symptom column, that is spaces before and after the word which are present are removed here. Further, we are filling the not a number values with zeros. As you can see here, we have not a number value here, while here it's zero. We are filled with it zero. And the next step, we have loaded and read our symptom severity dataset. In here, we have symptom as well as its severity. This is further used in our chatbot phase where our chatbot gives precaution to the user according to the severity of the disease. Like if the severity of the disease very way much more, then it advises to consult a doctor. If it's not very more or serious, then it advises to take care and give some precautions to it. So that's the purpose of this. We have these many unique symptoms in our data set. These are about 132 when calculated. Further, we have encoded our symptoms in data with symptom rank, as you can see in the output, until 17. In the next step, we have also tried to find out if there are any symptoms with no assigned rank to it. If was a symptom with no assigned rank to it, then we were about to assign it, but as you can see in the output, there's no symptoms with no rank. This is the data set of it. As we have already removed the values, here we can check that if there are again any columns that have zero values, so that we can drop it. As you can see, there are none. Further, this is the graph of it, which shows a straight line, which means there aren't any. The next step, we have declared, as we know, the features are symptoms and the label is our disease according to our data set. Further, we have splitted our data set into training and testing models, and this is the shapes of it, as you can see. In the next step, we have loaded our decision tree classifier and trained it. This is the accuracy of our decision tree classifier, while this is the cross-validation score. Further, we have also calculated the k-fold, its mean accuracy and standard deviation, where it is 96.54 and standard deviation as 2.93. For the model comparison, we have also used naive Bayes algorithm. And in here, as we trained our naive Bayes algorithm on it, we have got our accuracy as 0.87, while our cross-validation mean as 0.85, as you can see here. So both the decision tree classifier and naive Bayes are popular algorithms which will be used for chatbot to creating it. Hence, the decision tree classifier has more accuracy. We are going ahead with decision tree classifier, which is diseases. I mean, prognosis as declared before, but in our data set, which is diseases. Further splitting our data into training and trusting sets. And again, the decision tree classifier. training it. And in the next step, we have calculated the feature importances. Feature importance is nothing but we'll be getting the importance of the features, like what are the important features that they declare the output of the decision tree classifier, and they are arranged in descending order. How these features influence in getting our output from decision tree classifier. So for that, we'll be using this feature importances. This is a code for getting a voice message. Further, we have created dictionaries for severity as well as description list and precaution dictionary. Then we have defined our reduced data where we have grouped all of the disease names into one. Like as uh, as you can see in our data set, we have a lot of lines for a single disease. So we have grouped all of this for a single one so that the processing would be easy for us and checking would be easy. Further, we have calculated the condition function, which is, as I mentioned previously in the phase one, according to the severity, this is a calculation of that, where we'll be giving if our user need to consult a doctor or not. So in here, we have taken calculating this function where the severity is decided in here, like sum into days by length of expected list plus 1. If it's greater than 13, then you should take the consultant from doctor. While it's not, then you can take the precautions. The 13 is an average severity score, and hence we have taken 13 for that. Further, this is initializing our symptom dictionary and enumerating our columns, which means we'll be having it returns a tuple with its index as well as value. This is a dictionary where we have loading our symptom description, reading it. Now, after reading, this is the key, and this is the value key pair, and this is the value pair. As you can see in the description file, this is the key pair, while its description is a value pair. Coming to our previous code, the same goes with the severity. The first one, which is our symptom, will be our key pair, while its severity would be the value pair. We are creating a dictionary for that so that it could be easy for accessing. Further, the same goes with the precaution dictionary, where the row 0, which is our disease name, this is the key pair, and all of the precautions are a value pair. As you can see from this data set, this is the first drug reaction is our key, while this is a value pair. Further, this is the structure of our health key chatbot. Uh, Initializing the HEALBOT, and then we are inputting our name, age, by using simple if and else statements so that we give a valid age to it. And if not, it would give us a error message. And also the gender is asked further, where it gives an error message if the input is not correct according to it, then finally prints it. Further, we have checking pattern from the disease list and the input, where we have given a regular expression from our input and compiled it. Further searched it, then the searches are returned using a prediction list. And in here we have a secondary prediction based on our symptoms. In most of the cases, we don't get our second prediction, only in the cases where the model cannot decide upon one disease, we get our secondary prediction. The further is printing our disease. That is, our leaf node is printed here, which is our disease predicted is printed here using this function. This is nothing but our leaf node, which consists of our disease name. Further, this is the traversal to predict our disease. We are accessing the tree from the decision tree classifier. Further, this is all of the uh, feature names, that is symptoms. If it's uh, if it's not defined, we'll be giving it as an undefined, or if it's defined, we'll be keeping the feature name of it as it is. The next is again the chatbot asks the symptom of for experiencing or they're experiencing. It takes the input, checks pattern if it's not there or not. If it's there, then it gives searches related to it by pattern matching from the previous function which we have created. Then enumerating, which is it starts from 0, as you can see here, 0 to the given list, but it's predicted. Again, the chatbot asks from how many days he has been suffering. If it's not giving the perfect output, it asks for to enter a valid input. Then this is a recursive function to traverse through tree. Here, the inputs are node and depth. Generally, the node would be 0 as it starts from the root node, and the depth would be 1 as it starts from the root node. Further, this is the same function which we have used earlier, and we are using here a threshold value in order to decide whether it travels to the left of the decision tree or the right side of the decision tree. If the name is the same as this is input, that which is predicted here, that is which is on the node, then the value is 1. If it's not, then the value is 0. If the value is less than or equal to the threshold value which is calculated, then it goes to the left node. If not, it goes to the right side of the node in for further traversal in our decision tree. And further, it prints if this is not the case, then it directly prints our disease, and it asks further if we are experiencing any of the other related symptoms into the traversal, and it only accepts the yes or no. If it's not yes or no, then it tells us to provide the proper answers as yes or no. Then second prediction, and as I said, the severity is calculated and it is given insight on it, like whether to consult a doctor or not. This is the same for it. This is a precaution, so where the precautions will be reflected. As I said earlier, recursive function, it starts with the root code and having the depth of 1. We're calling it here. The same goes with these lines. Running it in our terminal. So my name is Shivani. My age, let's try with the W. It says invalid input, so I'll give a number. I'll give K. So it says enter from the above. I'll tell male. So this is my age, gender, name, enter the symptom like I would say NO. This is a pattern matching and it gives us the enumerated result like from 0 to 4. So select what you meant. I would say runny nose. From how many days I've been experiencing it? From 2 days. Are you experiencing any? This is a traversal. Fatigue? No. 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 Let's say yes. No.